Hi guys, so today we're going to talk about gas exchange in fish. For an efficient gas exchange to occur, it has to have a large surface area to volume ratio, which maximizes the area for diffusion. Secondly, it has to have a thin exchange surface, which provides a shorter diffusion pathway for the gases. The gas exchange surface has also have to be permeable, which provide an easier diffusion for the respiratory gas. And of course, a respiratory mechanism is required in order to provide a steep concentration gradient across the respiratory surface. A good blood supply is also there to maintain the concentration gradient of the gases like O2 and carbon dioxide. You can also say that a large or extensive capillary network instead of good blood supply. I think that would be more specific. And the last one is a moist respiratory surface, which is actually quite important because the gases they have to be in liquid form, if it makes sense. They have to be dissolved to liquid before they actually do the diffusion across the membrane. And these are all the things that help gas exchange, like in general, no matter it was like in human or in fish. They are just there to make the process more efficient. And now let's focus on gas exchange in fish. So the special respiratory surface for fish is their gills. And there are two different types of fish. So the first one we're going to talk about is the cartilaginous fish. As you can see in my simple little drawing, they actually have exposed gill slit instead of the operculum, which is in bony fish. And the gill slits, they cannot act as a pump to move the water over the gills, so it actually reduces the respiratory efficiency. And for cartilaginous fish, their blood and water flows are in the same directions, which is described as parallel flow. And parallel flow is actually inefficient because oxygen diffusion only happens until the concentrations are equal, and therefore the oxygen diffusion cannot occur across the whole gill lamella. So the oxygen concentration in the blood in cartilaginous fish is actually limited to 50%. To remember that cartilaginous fish, they actually have a less efficient gas exchange because of the parallel flow. I actually draw a very sad face on the shark, so I hope it can remind you about the inefficiency of gas exchange in cartilaginous fish, because shark is one of the kind of cartilaginous fish, so I use it as the example. So there is a graph over here which talk about the saturation with oxygen in cartilaginous fish, in the blood and in water. As you can see, the x-axis is talking about the distance along gill lamella, and the y-axis is talking about the saturation with oxygen. And we have two different lines. One is the red one is blood, and the blue one is talking about the water. So the further the distance along the gill lamella, there is actually a higher concentration of oxygen in blood. But as we can see, in water is a different case, because we can see a decreasing of concentration of oxygen in the water. And this is because of oxygen in water actually diffuses into the blood. However, we can see that there is a point until the two lines actually meet, which means that the oxygen saturation in both water and blood, they become equal. And after that, it literally just stays at the same level, which is 50% of the saturation of oxygen for both of blood and water. This is what we need to know about the graph, basically. And now let's talk about the bony fish. Bony fish is actually more exciting for me because, well, it just comes up a lot in the questions instead of cartilaginous fish. Okay, let's start it. In bony fish, they have a operculum, which is actually a closed one. If you still remember, like the gill slit in cartilaginous fish, they are exposed. And this one, it can act as a pump to pump the water over the gills, which makes it more efficient for the fish gas exchange in general, because more water can go through the gills within the same time frame. So in bony fish, the water and blood actually flows in an opposite directions, which is called the countercurrent flow. It is more efficient because water always have a higher oxygen concentration than in blood, which means that a steep concentration gradient is always maintained. So the oxygen diffuses across the whole gill and melee this time. So in conclusion, 80% about of the oxygen is actually diffused into the blood from the water. The percentage is from my exam board, which is Educast. I'm not sure about the other exam board. I'm not sure if they say like it's 80% or not, because it is actually more than 80%, like in fact. But just check it in case it's wrong for your exam board. Okay, now let's move on to the graph for the bony fish gas exchange. There are actually arrows this time for the water and blood flow as they travel in opposite directions. For the blue lines, which is the water, it travels down along the distance of gill lamella. But for the blood, which is the red line, it is pointing upwards, like the arrows is going up instead of down. So what does it mean? So it actually means that the further the distance along the gill lamella, there is a higher concentration of oxygen in blood and lower concentration of oxygen in water, until the concentration in blood is very high and the concentration in water is very low, which at that point they actually can't diffuse the oxygen anymore into the blood. Thank you for finishing the video. I hope it's helpful for you. And if you have any comments on my first ever YouTube video, please do comment below so I'll know about it and see how to improve about my video. And yes, thank you so much. See you next time. Bye.